So let's start the webinar. Thanks everyone for joining. Let me close this chat for now. You guys still have the option to put your notes in chat. I just close it for myself so that I can focus. So thanks everyone for joining. We are today very privileged to have Troy Magennis to talk to us about forecasting using data. Um, and yeah, let's get to it. So a little bit about Lean on Agile. So we started Lean on Agile last year as a webinar series to bring in the more experienced people or the good experienced people, because recently I learned not everyone like to be called thought leaders from Joanna Rotman. So I'm going to change this slide to say more a good experienced people to elevate ourselves. So there, and by end of the year, December, I started the podcast as well to give another medium for people to come and learn. So you can find all of the subscription links on leanonagile.com. We are available on any platform that you can think of. If there is any platform that we are not available on, let me know. I give you a prize. And if you don't like to subscribe to a podcast application, we are going to put our talks on the YouTube as well. So you can see the webinars there and the podcast. There are two different playlists, so you have the option to pick and choose. If you have missed, so the people on the left were the amazing guests that helped us to elevate our series of webinar and podcasts. Michael Hammond, Klaus Leopold, Ryan Ripley, Declan, Joanna Rotmans. And the people on the right are the people that are upcoming. And we have Troy in the middle. So we have already having Troy on the call. Bob Galen, Diana Larson, Gil Broza, we are going to have them on the show. So there are good people that I'm going to talk to, and I'm looking forward to learning more from them. I hope that you guys enjoy that as well. A quick announcement that we are going to start we call it Continuous Improvement Newsletter. It's focused on the CI tools and techniques and interesting articles, a download of material for the webinar and podcast, or a summary of that at a quarterly level. So we are not going to send you every month or every week, but at the quarterly level, what's going on. If you are local to the Toronto community, maybe something that's going on in the Toronto community or Canada-wide as well. So we are going to share those. A little about Troy. We are very privileged to have him on the show today or on the webinar. I get privileged to meet him at Agile 2018 when he was doing a keynote speaking there. It's an amazing and entertaining keynote, as well as a great message within the keynote that we need to look at the data as an Agile community. If you haven't seen that, you should take a look at that. It's available online. I'm going to send out the links. But he's mainly focused on data these days. And he founded this company, Focus Objective, with, I forgot his name. Yeah, I'm sorry for that. In 2011, and mostly around agile metrics and probabilistic forecasting. But he is mainly known as the guy with free spreadsheets. So if you haven't been on his website, so he provides amazing tools and resources to do all these things that he's talking about. He wrote a book, Forecasting and Simulating Software Development Project, which is freely available for you guys. He published it freely. The second link here, again, is resources on the Focus Objective website that they provide for free. And he is currently writing a blog on Medium, forecasting using data. So there are plenty of resources that you can learn from Troy himself. There are more learning opportunity from Troy. If you are in Toronto, there is a March 25th and 26th training that is already sold out. A wait list is available for that. I just recently realized that he announced another one for June 2nd and 3rd. Registration is open. And the flight level architecture, June 4th and 5th. Registration is open if you are interested. I'm going to send out the links, and I believe Troy already put the links in the chat as well. We are going to be very honored to have Troy to come to our Lean Agile Network community event on March 25th. We are going to announce that this Friday after we have our February meetup. If you are not part of Lean Agile Network, get onto that. The space is limited. We try to find the biggest space available is limited to 100 people. So, and I'm sure we are going to have a wait list for that as well. So if you're not on that, get on that, and on Friday, look for a notification coming in your email or in your app, however you're using the Meetup app. A little about flow of the session, and I promise I'll be quiet for the rest of the session. So we want this session to be a two-way interaction, not only Troy telling us what he thinks is best, but feedback loop to be there. But we don't want to be interruptive. So if you guys have any questions, put it in the chat, and at regular intervals, Troy will give us some opportunities to ask him those questions and have a conversation with him. If you have any questions and problems, I'm going to observe the chat, so you can send those notes to me, and I help you as much as I can. With all that being said, I'm going to hand it over to Troy to listen to him and learn more about forecasting using data. No.
All right, can you hear me now?
Yeah.
Okay. Typical. As soon as we switched over, the phone dropped out. There you go, the way things go. Thank you for being patient. Well, welcome to this slideshow, and thank God for video editing software, Shaheen. So, forecasting using data. So, yeah, my passions are probably a bit too much around data visualization and using data, and I don't really separate using data and forecasting. In fact, in my workshops, you know, I have 2 days, one day on metrics and one day on forecasting. And if I start the workshop on forecasting, the questions always come up, but what data do we need to forecast? And then I sort of, if I start the workshops on data, it comes around, well, how do we use that data to forecast? So all roads lead to Rome. And I want to, you know, I realized about 5 or 6 years ago, we did a lot of talking about data, but not a lot of doing with data. So I set out to try and find ways to get people to use their data in better ways and to help actually show using data what the impact of Agile was and how we can improve on that. So you mentioned everything I'm going to say during this talk, nothing I'm going to show is at a cost. Everything is free. You can just go and download it at any time. So I'll make sure you get the slides. Shaheen will send out a link to these. So nothing you see is beyond your capability of doing. You just need either Excel on a Mac or a PC, and in most cases, you just need Google Sheets, which is free. So this isn't a sales pitch for anything whatsoever. I'm just going to show you some of the tools I built to solve very specific forecasting problems and how I use them. So this is what I really first want to reset your expectations about forecasting, because I see a lot written about forecasting is about when will something be done, what's the date of when, project 7 will be finished and delivered to the market. And I want to realign you on that. If you're using forecasting just to target an end date, you're just at a binary, we hit it or we missed it. And you might be reluctant to take opportunities throughout the project because it would make the forecast slightly wrong and in error. Now, in our world, what we want to use forecasting for is to know earlier that the reality, which is absolutely right, which is absolutely what's happening on the ground, that reality and your expectation is diverging, and do something about it in a very light touch, very easy way. So I don't want you to be sort of thinking about forecasting as just a date-oriented task. I want you to think about it as being understanding what the future might be, and if you don't like what you see, making changes earlier. And this is the biggest problem I see when people go down the road of starting to use forecasts and data, is they expect the forecast to be absolutely accurate in all cases, and it will only be accurate if the future stays identical to the past in throughput, in team stability, that there are no more public holidays, that there are no snowstorms, that there are no factors which are outside of the project's control, which isn't represented in the historical data. So what forecasting does is help us see those system issues much, much faster. So this is the process. You're going to model a little bit of using historical data or what you expect the future to, how the future might unfold. You're going to forecast using that data to get an estimate about what you expect to happen, and then you're going to continuously compare reality and fix the model. And the model will always be wrong, and that's not the point. The model being wrong means that there's something that you learned, something happening in the real world, some real world context that you need to include in the model to make the model and forecast and actual converge better. So that's the lesson. Forecasting is about spotting what you didn't understand about the system or didn't account for in the system earlier, not about the date. So as long as you whip around this loop as fast as you can or as fast as you like, no matter what method you use, even if you just used a burn down chart or velocity, total remaining scope divided by average velocity, if the outcome turns out to be different, you want to start improving your model by factoring in something that you missed. So this is how it's done in the real world, and this is what I'm saying here is that if you've got a section of historical data, then you should only believe that the forward projection is going to be correct if the backward projection was correct. So often what you're going to do to test your forecast is actually take a bit of data that you actually have and remove it and train the model and do a forecast using just go back 3 months, remove the previous 3 months worth of data, go back to the 6-month point and use the 3 months from that point to the point. So take from -6 months to -3 months data, see if you can forecast the most recent 3 months using that data. And as long as you can do that, then you know your model is actually aligning with reality. So this is a big problem. When we just forecast a date, we don't have the ongoing ability to understand what we've missed in the system. And I want that, if I could get rid of one forecasting anti-pattern, that's it. It's only about forecasting the date. It's not about forecasting the system. So this is what I was just explaining. You're in July. July is the current month. What you're going to do is you're going to hide April, May, and June's data, and you're going to forecast using just January, February, March's data to see if you can actually get to the actual point of remaining stories that you have and know of now. So you model using these known truths, history. You test that it actually was able to forecast something that was fairly recent. And only if that model turns out to be true and you fix the model until it is true, do you actually go and forecast the future. And as long as you take this approach to forecasting, no matter what method you use, you're going to actually be proving that you can understand your system well enough and it's stable enough that you can forecast and end up with a good result. By forecasting and proving that step 2 there, that a known truth models correctly, you actually get everyone else around you along for the ride, understanding that this forecast model is actually working. So backtesting, it's called in the real world. All it really is you just hide some data you know to be true and see if you could have predicted it, and then move forward from there. So this is the key point I want you to think about. But forecasting is about detecting earlier that you're wrong. And until you can forecast something that you know happened, don't go off and staking your career or expectations or someone else's money based on a forecast you're going to do of the future, no matter what method you use. You know, I use some sort of slightly more complex mathematical models. I do exactly the same thing. I've got to prove they work to myself before I actually go and communicate to others. Any questions on that one so far? No, all good. Thank you, William. All right. So, step 1. I often get called in and people want to understand what the staff capacity should be in the future, or what the help desk ticket capacity needs to be, or what the sales might turn out to be in the future. This type of forecasting of what a future value might be is called time series forecasting. I'm sure many of you learned about it in school at some point in time, or any of you who are into machine learning or any statistics at all probably have done their fair bit of time series forecasting. So what it really is you know, here's a nice set of stable teams that are growing. This was 100 teams in a company I was doing some forecasting for. And this is just the total number of stories completed week over week in a cumulative form. So you can see that it actually looks like it's growing at a nice sort of, it's a curved rate, it's not linear. So they're actually growing faster in the more recent eras because they were adding staff and hiring superstar agile coaches like us. So it looks nice and stable, doesn't it? It looks like this process should be something that you could easily predict what a future value or throughput would be for a whole group in the company. Well, this is the same data shown in just the throughput values by team. So whenever we use any cumulative function, and I'm looking at you cumulative flow diagrams, and I'm looking at you burn-up diagrams, any cumulative projection looks like it's got a really nice, neat pattern that we're going to forecast the future, when in actual fact, it looks like a dog's breakfast. And this is important because depending on how far out we want to forecast, that would do a good job of forecasting out what we're going to likely be at in cumulative form next year. But if we're looking at next week, next sprint, next month, next quarter, we have to actually start looking at these patterns which occur in the data over time. And I don't actually see a lot of people looking at this data and sort of saying that it's possible to be forecasted, but it is. The problem is that there are so many different sort of slopes there. So even if you just took an average of all these slopes, it's not going to give you a very good reaction. I mean, look at what happens around Christmas times there, where throughput drops to 0. If your project happened to go over the December, January, New Year era, you know, you weren't getting that feature or project out the door on time. You were going to be at least a month late. So it matters when we start, and it matters that we incorporate these cyclical patterns in the data. You see, especially these ones. Now, anyone got a guess as to what these little drop-offs were? Put it in the chat window if you can guess what it was. Yeah, it's Christmas, that's right. But the root cause of it wasn't just it was Christmas, believe it or not. PTO, yep, that's right. So the office wasn't closed. PTO was correct, that people took the PTO. Why did they take their PTO? PI planning, absolutely. But it wasn't in this case. It was a HR policy. Imagine 100 people, 100 teams, average of 5 people, 600 people, going to zero for 2 months because of a HR policy. And the HR policy was if you didn't use your annual leave, you lost it. So everyone who worked at, midnight hours throughout the year up until December realized they would lose their 2 weeks annual leave if they didn't take it. So even though only 3 or 4% of them took that off, it was enough to break the dependency chain between the teams. So even at 2% absentee rate inside this company brought the entire flow of 100 teams to zero based on dependencies. And the HR policy was if you didn't use it by the end of the year, you lost it. And coronavirus, yeah, we'll probably see something similar to that soon. But there's nothing you can do. Look, I'll even look into here. There is nothing you can do on estimating story points that can have the same impact as a bad management and HR policy. Nothing at all. So stop arguing whether it's a 5 or 8 point story and start thinking about what are these contextual factors inside the organization which bring 100 teams to a standstill, because there's numerous of them. And you see some of them on this sheet. Look at these declines. That's the rumor of a reorg. That's when they shifted offices, and this is when they reformed new teams. Massive thrashing, massive uncertainty. Nothing you can do in estimating a story by story will have this impact. So a lot of the job of forecasting is to look at forecasting as a system, not as the sum of an individual story count or story point estimate. So there are 3 components to data when we're looking at data and projecting it moving forward. Trend, which is what you sort of roughly see if you run a line visually through all of that dog's breakfast. Then there's a seasonality pattern, which is roughly that if you're doing sprints, sometimes teams, naughty, don't sign off work progressively as they go through. They wait to the hour before the planning meeting, and then they sign off their stories. Well, that means 1 week will be very low, and the next week will be very high in throughput or velocity. And that's what we would call a seasonality pattern. In the real world, it's often that in winter we don't sell ice cream. But in our world, our seasonality patterns happen because of meeting cadences, planning cadences, different things like that, quarterly release cycles. Just before a release goes out, sometimes we focus on defects more than new work, so we get less work through. All of these seasonality patterns are important if you're trying to predict what a value is going to be in the near term or the medium term, next week, next sprint, next month. And then there's this noise, there's this special causes, which that Christmas HR policy indicate. There are special events that happen that actually, sometimes I make it look like there's small noise on this one, but sometimes those special factors like that Christmas vacation have a massive impact. So don't always think of any of these 3 as being overriding, as being important to forecast. You actually need to think about what factors in my context and world could cause one of these 3 categories of forecast to be the overriding result, and it will differ. So long term, it's best to use the trend as the predictor. Medium term, looking at a quarter or 6 months, the trend plus those seasonality factors. But if you're worried about, if you're forecasting in November something that you'd expect to be delivered around about December or January, in that previous company's world, it's those special concerns of what happens in December and January, or in Europe, it's what happens in August that actually will have the overriding impact on any forecast that you give. So you can't just sort of hand this over to a computer algorithm to actually do these forecasts. You actually have to keep a human in the loop, because the humans are really good at spotting those special causes where the computer cannot. And the computer can assist with seasonality, but you need to actually apply it to yourself. Or there's no way the computer could know in advance that we reorg every 3 months. It might spot some hints in the data, but you need to actually give it a helping hand on that. So what factors might impact the demand of ice cream sales? Throw it in the chat window. Give me a factor. Cows on strike, yeah, that happens. Weather, yeah, certainly. And then what is weather related to? Yep. Hot outside, vacation time, all good answers. Tourist season, warm, that's right. So you're right, temperature does actually correlate to ice cream sales. And what does temperature I'll say it properly. What does temperature correlate to? Seasons. Someone said it. So the seasonality factor for ice cream sales is actually that during summer we sell more ice cream than during winter. And it's often easier to forecast. You can't, if you're forecasting in temperature, you've got to sort of guess a range of what it's going to be in the future. And often we just use those 4 nice categories of season to handle that. And we just don't account for nice. Yes. Thanks, Harry, for that. You're somewhere north. All right. So special causes I've had the privilege of presiding over a disastrous forecast for. TV advertisements. Oftentimes, if you're trying to forecast the load on your servers or what people are actually going to, how much they're going to call your help desk, or they're going to actually do a checkout for credit card sales, is being seen on TV. And, there are some great ones there in the UK. I was involved with lastminute.com and Travelocity, which every time lastminute.com ran a TV campaign called When It's Gone, It's Gone. So it was a limited number of fares that were ridiculously low, like $15 fares from, to Paris to party, that sort of stuff. The website would go up maybe 1,000, 2,000% on its traffic. You've got to be ready for that. So the special cause that you wanted to talk about was loop marketing into the loop and sort of saying, what's our TV ad campaign schedule? And the same thing on sponsoring events on TV. Travelocity did the Amazing Race. On the Sunday nights, there were always people searching for vacation spots near the spots that were featured in that advertisement. So I needed to know what cities they were going to be showing on that week to know that we could pre-cache those search results for those cities on flights. Otherwise, we would bring down the flight reservation system. Most people were just looking. Your servers don't care that they're just looking. They just care that they're getting hot. And we need to start sort of looking at that and bringing that special cause context into the room. The Michael Jackson campaign, unfortunately, tragically died. But he died after the tickets were sold to his most recent concert. And we had enough capacity to sell tickets. We didn't have enough capacity to refund tickets. So it was a special event that we could never have predicted in advance. Iceland volcanoes changed travel patterns around the world. All of a sudden, the number of searches for hotels in Europe for people who were stuck, who couldn't get to the US, or people in the US who were stuck that couldn't get to Europe, completely changed the patterns of sales around what we were expecting in the load and capacity based on server load. So even though you may not be forecasting in your world the help desk capacity, the searches, the number of server capacity that you need in reserve, I want you to take the message being that what you are forecasting does have special cause variation. Some of these factors, there are factors that you know about that could really blow up any forecast you do using any simplistic method. And I want you to start thinking about what those factors are. So I give you a spreadsheet to do this, and one of them is just a very easy, you just start throwing in the date a date for every time something came in. You can have multiple values on the same day. What you're doing is you're taking account of the number of things that you know happened, the number of ice creams sold, the number of searches for France, the number of tickets you sold for a concert, any value that you want to look at, the number of stories that got completed. Hey, there's one we're not used to. So you capture just the date of the incoming demand. And what this spreadsheet does is it goes in the blue, it plots the actuals for you. And then in the gray dashed line, it does a forecast forward using those same patterns and using that same trend line. And it also forecasts it backwards, because remember I told you that was good practice. So if we see that this pattern of lines roughly correlates to the actuals, we can take a guess that going forward, these dashed lines have some validity in being a good way to predict what's going to happen in the future. And the spreadsheet also puts a circle around the ones where we got it wildly wrong, where our forecast versus actual was particularly different. And that's your trigger to sort of say, why? What happened? What happened on Wednesday that actually causes this one and this one to be something different? And probably in this case, it was the fact that we had our sprint planning every Wednesday. So there was a huge sign off of work just before the sprint planning meeting. So I don't see the forecast being wrong as an error. I see it being as a learning opportunity to understand what those special cause variation points are. And the spreadsheet will help you sort of do that. So it's just go to bit.ly demand forecaster and download it. It's just a spreadsheet. There are no macros. It's just a plain spreadsheet that does this simplistic time series forecasting with the trend, the seasonality, and oh, it's broken. Well, I will get you a new link at some point in time. Sorry, Harry. Yeah, can't find it right now, but I will fix the link later. They must have taken it down. All right, I'll get you a good link. Special calls. There we go. So, know what factors are important in your context. Trend, patterns, and special cause variation. There is no one forecasting method that is right for long-term, medium-term, and short-term. Forecasting. You're always going to have to blend these three factors together. And what you're going to have to do there is use your brain. You're going to have to think about, are we entering an era or doing something so brand new that special cause variation is going to be important? Or has the team changed substantially enough that it doesn't matter what the historical trend is, there's going to be a new trend forming for the future? Your job is to add that human context as to what is actually not working and why. So you can't hand that over to a computer, and you can't just take a nice simplistic, just sum up the number of stories remaining, divide it by the historical velocity, and expect to always nail your future forecast. You've got to apply the patterns and the special causes. Any questions so far?
I have one question, Troy, if you don't
Okay.
mind. So this is, I'm not sure if it's typical of other coaches or the situation that they were in, or you have seen that. But the challenge is that sometimes you get to an engagement and they ask you, help me with prediction and be able to be more predictable, whilst they don't have, like, there's no historical data even available to look at that and find out if your model is correct and then move on.
Yeah.
What are your thoughts about that? What would you do in that situation?
It's a great question. So often when you come in, even if there is historical data, you might be best to ignore it because you need to forecast something brand new. I'm going to show a few examples of that in a second. That is where the rest of the talk goes, and we're talking about how to incorporate probabilistic forecasting in estimates and ranges rather than actual historical data. And we always or often have to start there. So So let me hold that question over for the next section and see how we actually move on and see how I answer it. But the answer is you have to drop back into estimates. Okay. And then the second answer is those estimates can't be just discrete values, they have to be ranges. We think the new team can get between 2 and 5 things done per week. We think that the number of stories in the project is between 20 and 30 stories. So we want to be less exact with our inputs and still be able to do the math correctly to understand what the likelihood of any right outcome is. And that's what we call Monte Carlo forecasting, which is what we're going to look at now. Okay. Thanks for the question. Forecasting duration. So here we are. Yeah, but how long will a feature take? Great question. This is the ubiquitous one that we often get. It's often the entry point. It's what people in Agile are currently most frustrated about giving an answer to. If it's something no one in the world has ever done before, being asked this question can feel infuriating, can't it? Like, I don't know. We've never done it before. No one's ever done it before, but you want me to go on the record with the 17th of July. It's absurd, but common. So let's look at how other people handle this sort of uncertainty. Google Maps. Does anyone use Google Maps for navigating? Probably do. Let's look at what they do for what they're forecasting and how they approach the task of giving an actual value there. Well, for one thing is they don't give one option, they give multiple options. What do we do in software? We say it's going to be the 27th of July, and the team just assumes and picks one way of doing it. Even though there were multiple ways, we could cut the feature into 2 parts. We could deliver most of the value, and then we could get back to doing refining. No, when we're asked to give a single date, we give exactly that, a single date. And we don't look at all of the different ways of transport options, different ways of delivering it, using different teams, focusing one team fully on it while the other teams do business as usual, splitting it across multiple teams and giving them all a bit of a go at it. No, we go out and just give a single value. Notice that they don't say 27th of July, they say it's going to take 21 minutes or 21 weeks. They do all the comparisons about what options you should do without giving you a time that you're going to arrive. They only give you a time that you are going to arrive when you say you have started. And the number one error I see when I go into actual companies to diagnose why they feel that their forecast was wrong, anyone guess what the number one error is? Start date. Projects, when they've done the forecasting, yeah, humans, that's right. So what happens is we forecast next quarter, assuming it's going to start right at the beginning of that quarter, and then something in the previous project carries over. It is the start date, which is always the most fragile input to any forecast that I find. So Google don't fall for that. Google don't give you an estimated time of arrival until you actually start. And once you do start, they continuously update that time remaining using the latest traffic data, using the latest, most recent data. So this is what I'm going to say, that if you're currently giving a forecast, even though that your teams looked at multiple ways to deliver a feature, different designs, different complexities, start surfacing a very simple forecast using multiple options. Let someone else actually choose which one is right to do. If you're giving a calendar date for when something will be done, stop it. Start giving durations for how long it's going to take once it's started. If the original date starts, in normal forecast, we get near the end and realize it's not all going to fit and then rapidly change scope, stop it. The moment that you actually know that a feature isn't at risk and isn't going to make it, even if it's in the first couple of months or weeks of a feature or project delivery, surface it and start making smaller changes to the forecast and scope earlier rather than a massive one at the end. by far, I find the executive teams who bring me in and scream that they don't like that they're unpredictable. What they really don't like, when I dig into what the cause is they just don't like being last to know. And at the moment, they feel like they're last to know that something's going to be late, and that the team's doing everything they can to try and force it in, even though that's a fool's errand and it can't be done. So that's how I want you to start sort of thinking about, learn from Google and how Google handle uncertainty. And what we're going to do now is look at how to bring that together in our world and do that in the software scope. So first of all, why do we want these more complex methods? And you heard, as Shaheen sort of say earlier, that a lot of the techniques I promote is in the realm of probabilistic forecasting, which is just a really sort of scientifically sexy word for saying that we don't give one result, we give you the chance of a result occurring. And why do we do that? And often because if we just project an average line forward, like we do with burn-ups or velocity or scope and stuff like that, what happens is we're giving an answer at the 50th percentile, right in the center. That's what averaging does, is it takes all the bumps out and just projects what the middle number is. And the middle number is 50% chance of being late, 50% chance of being on time. And that's often not good enough if other people are taking the date we're giving and making follow-on decisions based on that. So I need you to start realizing what probabilistic forecasting does is it allows us to shift to a higher level of certainty, and sort of saying we're 80% certain to deliver within 16 weeks. Remember, don't give a date until you have a start date. Stick with duration. So how does it work? Well, with normal math, we would just sort of say we got an amount of work remaining, 25 stories. We roughly get, on average, 5 stories done per week. It's going to take 5 weeks to deliver. That's traditional normal math. Now, all we're doing in probabilistic math is we're sort of saying we're going to put some uncertainty in those numbers. It's between 20 and 30 stories divided we get between 1 and 5 things done per week. So it's going to take between 4 to 30 weeks to do. Now, that's often shocking to people because the number they've got burnt in their brain using just intuitive math is 5 weeks. And now we're going to give them an answer, it's between 4 and 30 weeks. That would scare them. And, we know that the 30-week option really has a low chance of occurring. So we need to add some color to the 40 to 30 so that people don't freak out at being, really? It could take up to 30 weeks? And it could. If every week, if the amount of work ends up being worst case, 30 stories, and the rate that we do the work ends up being worst case, we just get 1 thing done per week, it could be 30 weeks. But that's not the most likely outcome. And what I'm sort of going to show you is some spreadsheets where you start inserting your data. You might start off there, as Shaheen's question alluded to, not knowing what your historical data is. So you would say, we're going to start off our forecast using an estimate between 1 to 5. But when you start getting data, we're going to throw data into that denominator rather than just your estimate. So we start off with an estimate and we move to data when we start getting it. And that's what we're going to do. And how does it work? Well, when we start having those historical sets of data, here's a burn-up chart of the rate that we're completing work. And some weeks you see we were really slow, and some weeks we got a lot done and we're burning up at a faster rate. And then our backlog of work was changing. We started off with a certain amount, and then it grew and grew as we added defects and split work. And in a traditional world, what we would do is we would sort of take a projection line of those two, and where they intersect, that's the date that we would give people. And often that's a valid way of doing it, and that is a possibility that this is the actual date that would occur. But how likely is it? And that's what we're sort of saying using what's called the FLAW of averages. The FLAW of averages says that that date is only 50% likely. There's a 50% chance it will be less, a 50% chance we will be more. So what we're trying to do with probabilistic forecasting is get a bit of a deeper understanding. The backlog does grow too. I've simplified it here because I'm just not that good at PowerPoint. But we want to actually understand what the likelihood of the possibility of those ranges are. So how do we do it? Well, what Monte Carlo forecasting does, it sort of says, in my world, we could throw out a line saying that we're going to be the slowest rate. And that was that 30 weeks that you saw in that previous diagram. And then my boss would actually use the throughput history of the fastest rate. And that would be the 4 weeks that you saw on the previous sort of slide. So we know that that's the actual range. And each of those are possible, but we don't know how likely they are. And the way we determine likelihood is we just start randomly throwing up random possibilities by resampling our historical data thousands and thousands of times, and it starts building the shape distribution about how likely each date is. And then all we do to find the 85th percentile, to be 85% certain, is 85% of the lines will be at that date or to the left, that duration or earlier. So all probabilistic forecasting does is randomly produce a set of possible outcomes and then count how many are on or before a certain date based on how certain and likely we want the result to be. And that is the sum total of complexity around Monte Carlo forecasting. So hopefully this link works. Someone test it, please. Is the throughput forecast is it gives you a start date, and in the order of, I think, sensitivity, you start off with a start date that if you want it to turn into a date, you leave the start date out if you just want to stay in duration, which is what I would do. Don't commit to a start date until you know the team is formed, until you know that they're focused on this work. Take that lesson away. So then you got to guess the scope range. And I make it a range, 20 to 30 stories. I don't make you say it's going to be 22 stories or 23 stories. If there's uncertainty, I want you to actually put it in here. And then you're going to put it, initially, you're going to put an estimate in of how many stories per week or per sprint that this team is going to do. And what the result is of just those inputs alone is the spreadsheet solves the Monte Carlo. What it does is it does exactly like what that previous set of slides did. It just builds random possibilities going down the page there. Every one of those gray lines is a possible scope, and it gives you a chance in that spreadsheet to put the actual amount of remaining work in, so you can see the orange line shows where you're going to be. And you're right, if the backlog grows, all of a sudden your actual line will fall outside of this rat's nest of possible lines. And that's your indication that there's a system issue. I haven't accounted for scope growth as good as I should. And then you would go back and bump up your high guess in the spreadsheet to account for it. And the output it gives you is, again, a set of dates or a set of durations, but it gives you this context of how frequently they occurred in that simulation. And we can take a 50% chance and we can sort of move it up and sort of say, no, we're going to communicate 85% chance to other people. And that's Monte Carlo forecasting in a nutshell. It's just about being able to take the range estimates that we give or the actual data that we have and add a bit more color around certainty of a certain date occurring. And, it gives you this nice little table where it sort of says 85% chance it's going to take 11 weeks, 17th of the 1st, 2020 is the date that was going to be delivered. So yeah, that's the issue here, is we're able to take historical data or range estimates and convert them into something which gives us a way to understand how likely a date is to occur, not just get a single date of a 50% likelihood. All right, so Shaheen, that's how you would do it before you had historical data. You would actually use those range estimates. And then when data does start coming in from the team, you would start adding it into another sheet on the spreadsheet. And what it does then is the forecast will now use your data rather than that range estimate. So this is a way you start off with a very broad range estimate, and as the project gets going, you start entering your actual data in, and you start seeing more and more vivid likely outcomes get tighter and tighter and tighter as you go.
Okay.
So it's all about sort of starting off wide and getting narrower and narrower and narrower as you move along. So a small variation of it, and this spreadsheet is the one everyone knows me for, but I don't use it. I actually use one which actually you split the features out, and it gives you a green tick mark or check mark of which features are going to hit a certain target date. So what I'm trying to do is get people to sort of break down the size of feature 3 into 2 features because it's too damn big and it's likely to miss the target date. So I find this spreadsheet isn't you saying no, it's saying that it's unlikely that feature 4 is going to make it. And if we want it to make it, how can we split feature 4, or can we change the order of feature and drop feature 3 to get feature 4? What can we do to understand what we're going to get here? So it's the conversation around this sheet again it's about how can we get the right features and as many features to hit a target date as possible. It's not just your team is committed to the 17th of July for this feature alone. And this is a much more tangible and actionable forecast discussion than just looking at a single date and sort of saying, just work harder, just add more people. I'm sick of your excuses. No, this is actually about, we want to get the right work delivered within this period of time. Help us option it. So question in there now, can we account for special circumstances, reform teams in the forecast? Yes, you can. First thing you do when a team completely reforms is you delete the historical data and you move back to using range estimates for throughput and the delivery rate. Also in this spreadsheet is the ability to put adjustments in by month, and you know why I added that feature, right? So when I was at that other company of 100, I made December and January have a fraction of, I multiplied the throughput history by 0.2, so only 20% of the throughput got through. In Europe, I would multiply August by 0.2. So yes, both of these spreadsheets actually help you account for those special circumstances that you need to put in. And you need to, the biggest part about it is that they're on the same sheet. They're not hidden somewhere else. So you're actually surfacing the assumptions that are being made to make this forecast come true, and you're handing it over to people who have the responsibility to fix it, which isn't the team. So what happens when the teams get told to forecast? They're actually having to account for things that they can't control, and that's infuriating. And what's more is it doesn't help the organization change the system to stop that occurring in the future. So yeah, great question. Yeah, the first thing you do when you delete the teams is start going and putting a range estimate in, and it's normally what happens then is the date range gets much larger, the minimum maximum grows, and it's actually going to be the infuriating for the people who actually decided to blow up the teams, and you can tell them, please stop blowing up my teams. It means we have to stop using the historical data and you're getting bad forecasts. All right. I think, so what the other question I get is how many historical samples you should use. And I'm going to say very quickly that it's far less than what you expect. You're going to need to start using samples around about when you have 4 to 7 historical pieces of data. So delete the data because the team got destroyed. Start using data again once you get 4 or 5 samples from the new team. It's not about thousands or hundreds of samples. It's about 4 to 7 samples. And definitely by 7 to 15, you're actually better off deleting any data older than the previous 15 samples because the team and context has changed so much, those old samples are no longer valid. So I see far more errors introduced into forecasts because people keep old data than I do not having enough data. So start looking for reasons to delete data, and rather than being a hoarder. I see a lot of hoarders out there, especially tools which actually automatically do these forecasts for you. They use every bit of data they have back to 2002, and your team isn't the same as it was in 2002. So using that historical data from then is just adding to your forecast error. So be selective. All right, so why do we do all this? We want to avoid the flaw of averages of just projecting forward a date which has a 50% chance of happening. There's never one answer because we have uncertainty in all of our inputs about the date we start, about the scope, and about the rate that we do the work. And I want you to start thinking about what data you delete rather than what data you use in your samples, because if there was a one data anomaly, it shouldn't be the overriding value which causes your forecast in the future to be incorrectly optimistic or incorrectly pessimistic. And that's it for this side of it. I know one of the links, it sounded like the demand forecasting link dropped off somehow. I will correct it and get that back live for you. Hopefully the others are okay. Happy to take questions now.
I know some people has left because they had to run to meetings, but if there are any questions, this is the chance, guys.
I bored them all. They've gone to sleep, Shaheen.
Yeah. We have one question.
Is there a way to feedback how accurate teams were in estimating the ranges of the features after the features have been developed? Great question. So yes, there is, of course. What I tend to do is I keep a post-it note around when the teams estimate a feature, how many stories were in a feature, and I only keep it to the number of stories in a feature. So they say there's between 10 and 15 stories in a feature. What I do is I put that on a board, on a wall somewhere, and I keep them ordered. And then when the actual feature finishes, I go through and I count up the number and I cross out the range and I put the actual number. And I still keep that on a wall. And what that helps is next time the team has something similar to that feature, they can look along that wall and sort of saying, where we said this feature was adding a credit card provider for American Express was 7 to 10 stories that turned out to be 15. When they get a feature that says now implement Bitcoin or implement Diners Club, they can go back to that wall and sort of saying, last time we estimated low for that feature, but it looks like it's more likely going to be 15. So let's say between 12 and 20, and they start sort of bringing through that estimate of the range over time. So I'm not using their error for any other reason other than helping them in the future recognize that they forgot about localization, that they forgot about performance testing, that there were things that they also had to do that they forgot about. So yeah, I keep it very low key. I don't tell the team, hey, you suck, you got the forecast of number of stories wrong. I use it for saying, why did we get it wrong and what did we miss? And normally it was sort of, they didn't add a story to work with an outside vendor to get the login working for the API or something like that. So your job isn't to say you're wrong. Your job is to make them remember for next time what they need to account for that they missed. All right, and all the URLs work. I just heard that. They're case sensitive. I think that was probably why the other one didn't work before. Any other questions there? I see one here. Sorry, I need to log off.
We have one from
that.
It says, before a project starts, we make estimates low, high, and expected. What are your thoughts on that?
Low, high, and expected. Yeah, I think that's a bad. I think it's good for the team to do. I would still do the forecast using the low and the high. Now, I don't want to get into it too deeply. There is a big benefit in using the range between the low and the high and not influencing it with the speculation about what the most likely is going to be. Now, using low and the high will give you the worst case range in the result. which is what you want. But the moment that you start adding actual in there and biasing how far between the low and the high you think it's going to be, you prematurely narrow the range. And that's possibly good, but it's also possibly going to be a big source of error if the team is biased in one way or another. So the job of the estimates of the low and the high and the psychology around it is to make sure that the team is absolutely confident, 95% sure, that the actual value will fall within that range. And I actually find I need to coach people to make that range wider than narrower. So I've got a problem with anything that makes the team narrow the range, because I feel that it actually makes the team, it influences the results and it doesn't give us a vivid range. Now, the reason the range that we use in those inputs doesn't matter as much is because when they're combined together, we end up with essentially weighted set of outcomes anyway. So the ranges don't matter as much as you expect. But it sure is good to know that those ranges might and could occur. And this happened in the US election. You know, people mistook that a 5% chance of Donald Trump becoming president meant zero chance. And it wasn't a zero chance. It was actually a possible outcome that happened to occur. That's not surprising. But if we started saying that it was really unlikely that that occurred, now people have an expectation that Donald Trump wouldn't win. And he did, and people were shocked. So whereas the most likely was that Hillary Clinton was going to win, people excluded that from their mindset because we actually said a low chance meant zero chance, and that's not true. So great question, and I know it's done a lot in other fields. I just would sort of caution you about setting up the psychology of that would exclude possibilities that may occur, and be careful there. Shaheen, what was another question?
Harry saying the black swan effect, I think.
Yeah, absolutely, Harry. Good point. The black swan effect, for people who are unaware, are events which have a huge impact but a very low likelihood, so low that a lot of people don't even realize that they're a possibility. Yep. What can you say? Yeah. Certainly, you can increase your chances of finding them by actually asking an open-end question to the team when you forecast. Okay, that's great. I'm glad you gave me all the forecast and number of stories. But what could go wrong that means we could never ship this? Or what could go wrong that could make this become twice or 3 or 4 times longer than we expected? And often, that will terrify you that the team will give you 5 or 6 really good reasons why the forecast they just gave you is completely reckless to give to anyone else, and you need to coach them on getting them. But often it's someone quiet in the corner of the room that's sweating, knows that there's something that's possibly to occur. They're too scared to say it because every time they do, everyone just glares at them and gives them a stink eye. Mm-hmm. And you need to find safe ways of getting that data to surface earlier. What's going to happen is the actuals are going to start diverging so far from your forecast that it's going to come out anyway. So you need to start giving credit to people who bring that bad news forward earlier, and find a way of give them a wall of saying the wall of disaster where they can put anonymous Post-it notes up, something like that. Yeah. And then I set up such a wall in one company, and I watched one guy look around thinking no one was looking, put a Post-it note on the bad news wall, and then sprint up the stairs, hoping that he wasn't seen. But it was actually something that was going to come true, and it was just honesty. So the black swan effect, all you can do is make a safe space where people can raise them earlier.
Mm-hmm. Again,
okay.
Thank you, Troy, for spending the time with us. I don't think there is more questions left. Again, I'm going to, I forgot Adam Yuri was the other person at Focus Objective, so I forgot his name. Sorry for that. And I'm going to send out an email if the technology helped me with all the links for you guys. And hope we are going to see Troy in Toronto soon. for those of you that in Toronto joined us. Thank you, Troy.
Okay, listen, thank you. And thank you everyone for joining from around the world. Bye, Shane.
Bye.